yesterday we looked at one way of drawing a straight line using the gradient and a point that is on the line. So I said if you're given the gradient, let's say your gradient is half, and then you are told that the point 2, 3 lies on the line. What you need to remember about the gradient is that the gradient is equal to delta y over delta x. Then the numerator will tell you how many units to move up or down, and the denominator will tell you how many units to move left or right. So you draw your x and y axis. So this is your x-axis, that is your y-axis. Then you will plot the point 2, 3. 2, 3 is somewhere here. So this is 2 and that is 3. Then what you do is you move, the numerator is 1. That means I will move 1 unit up. So I move 1 unit up, I end up at 4. And then I move 2 units to the right because that is delta x. So I go from here, I go 1, 2 units. So I was at 2, then this is 3, then I will end up at 4 over there. So the new point on the line, or the other point on the line, is this point over here, which is 4, 4. And then I take my ruler and then I connect them. I don't know if it passes through the origin. On a paper it's easier to tell what it passes through. Okay, so then you can read what your x and y intercepts are, and then you label your line like that. So it's just moving. Here I moved 1 unit, and then this side I moved 2 units. So I just look at my gradient. That tells me how many units up or down to move. And then when I get to the next point, I just connect them using a straight line. So we also talked about lines that are parallel. We said lines are parallel if they have the same gradient. So parallel lines have equal gradients. So M1 is equal to M2. So you'll write both of them in standard form, where y is the subject of the formula, and then you compare the coefficients of x. If they're the same, then the two lines are parallel. And then perpendicular lines. These are lines where they meet at a 90-degree angle, and we say that the product of the two gradients is equal to -1. Okay, or you can say one gradient is the negative reciprocal of the other one. So if you have the two equations of the lines in standard form, you multiply their gradients. If the answer is equal to -1, then those lines are perpendicular. I also mentioned that perpendicular and parallel are not, it's not one or the other. If they're not perpendicular, then it means they're parallel, or if they are not parallel, it means they're perpendicular. No. So you can have lines that are not parallel as well as not perpendicular, because perpendicular just means the angle between them is 90 degrees. You can have another angle between them, 60 degrees, 35 degrees. So it's not always parallel or perpendicular. So if I ask you, check, are these two lines parallel or perpendicular? You check, you see they're not parallel. It doesn't mean you conclude that they're perpendicular. You still need to check this condition over here. Make sure that they are perpendicular. Okay, then look at one last example on the straight line. We are given this sketch over here. This is from the exercise 4.7.1. We are given a straight line like that. Okay, the arrows just means it goes on upwards as well as downwards. Then we are told that the gradient here, given this 3 and 2, and then we are told that this point over here is 2. So we have to come up with this equation just by looking at what we are given. Now we know that our gradient is delta y over delta x, and this 3 here, this is delta y, and this 2 over here, this is my delta x, because delta y is the same irregardless of any 2 points that you pick. So even if I pick these 2 points over there, when I work out delta y over delta x, I will still end up with 3 over 4. Okay, so it may be 0.3 over 0.4, but in its simplest form, it is still 3 over 4. So my gradient m, this is delta y over delta x. So this is, sorry, in the book it's 4. In the notes I wrote 2. I don't know why. Okay, this is 4. So this is 3 over 4. Okay, and then we know that in standard form our line is y is equal to mx plus c. This m, I just worked it out over there, and c is the y-intercept which I'm given over there. So I'll just substitute c as 2. Then I have my equation of the line. So here I have y, this is equal to m 3 over 4x, and then my c is 2. So even without doing any calculations, just by looking at the sketch that I am given, I can work out the equation of the line. So remember the gradient delta y over delta x, then your c is just the y-intercept that is given to you in the sketch. Okay. Do we have any questions on drawing the line using this method? Okay, then if there are no questions, then we look at the last topic of the semester, which is the parabola. Now we've talked about the parabola before when we were looking at quadratic equations. I would ask you, does this parabola open upwards or does it open downwards? You were able to tell me. Now what we do is we sketch the parabola. If you're asked to draw a parabola, it means that you must use a table with your points. So you get your points and then you plot those points and then connect them. But usually what we will ask you to do is sketch. When you draw, it must be on graph paper. When you sketch, it doesn't have to be on graph paper. It's just a rough sketch so that anybody can see, oh, this is what the parabola looks like. Okay, now your parabola in general has this equation. Y is equal to ax squared plus bx plus c. Now the parabolas we will draw will either open upwards or they will open downwards. There are parabolas that open sideways, but these are for advanced classes, so we will only look at these 2 parabolas. Okay, just a moment. Okay, now the way to tell which one it is you have to draw, whether it opens upwards or downwards, depends on your value of A. When a is greater than 0, it opens upwards. When a is less than 0, it opens downwards. So that's how you would tell. Now, when you're sketching a parabola, there are a few things that you need to tick off or check to make sure that you have drawn your parabola correctly. The first one is the shape. So this will be, does it open upwards or does it open downwards? Then you have to indicate your maximum or minimum turning point. And then we have the y-intercept. Now the y-intercept, this is where it cuts the y-axis, and we know that at the y-intercept, x is equal to 0. And then we have the x-intercept. These are also called the roots sometimes, and this is where y is equal to 0. Okay, and then the last thing you should indicate on your sketch is the axis of symmetry. Now, an axis of symmetry, this is just a line that divides your parabola into two equal parts. So whenever you draw any parabola, let's say you draw like that, there is a line that cuts it into two equal parts. If it opens downwards, this line over here, these two lines, these are your axis of symmetry. Okay, so they are the lines that divide your parabola into two equal parts. Notice that they pass through the minimum point as well as the maximum point, depending on how your parabola opens up. Okay, so the best way to get the hang of how to sketch a parabola is to look at an example. So we will sketch one, we will make sure we do all these things. We determine our shape. Does it open upwards or downwards? Does it have a minimum or maximum? What are the coordinates of the minimum or maximum? What are the intercepts? And what is the axis of symmetry? So we look at our first example. We have y is equal to, say, y plus x squared minus 2x minus 3. This is equal to 0. Now, first thing you must do is rewrite it in standard form. That means y is the subject of the formula. So making y the subject of the formula, everything else will go to the other side. I have y by itself. So I will have y is equal to negative x squared minus plus 2x plus 3. So I've written it in standard form. Now I need to determine the shape. So I look at the coefficient of x squared, that is negative 1. Negative 1 is less than 0, so my parabola will open downwards. Okay, now that I know how it opens, I need to work out the maximum turning point, because if it opens downwards, then there's a point right there at the top of the parabola, which is the maximum. Okay, so to work out the maximum turning point, the x-coordinate of the maximum turning point is given by minus b over 2a. Then when I work out the x-coordinate, I will substitute it back into the original equation, which is this one here, and then get the y value. So the x-coordinate, this is where I have x is equal to minus b over 2a. This minus b over 2a, you can also work it out by completing the square. If you complete the square, you have x minus p squared in your brackets. That p is your x-coordinate. Or you can just remember, use this formula if you want to work out the x-coordinate. So I look at my equation when I wrote it in standard form. A is -1 and B is +2. So this means that x is equal to -b divided by 2 times 2 times a, which is -1. And this just gives me x is equal to 1. Now that I have the x coordinate of the maximum point, I need to work out the y coordinate. So we know that y is equal to negative x squared. So it's negative 1 squared plus 2 times 1 plus 3. So I'm using this equation over here. All right, this, just work it out. Negative 1 squared plus 2 plus 3, this is equal to 4. So the maximum turning point has the coordinates 1, 4. So you write them x, y. So the x is there. We worked it out by saying negative b over 2a. And then the y, we substituted this x value into the equation for y, and then we got 4. So this is one of the points that I am going to plot. Then we said we need the shape, which we got. It opens downwards. The maximum we got, which is 1, 4. Now we need the y-intercept. So the y-intercept, we say that x is equal to 0. So I write my equation again, and then wherever I have x, I will put 0. So it's negative 0 squared plus 2 times 0 plus 3. And this just gives me 3. So the y-intercept will have coordinates 0, 3, because x is 0. So the x coordinate is 0, and the y coordinate is what I worked out over there. So keep all these coordinates in mind, because those are the points that we are going to plot. The first one is this one, 1, 4. Then we have 0, 3. And then we need the x-intercept, or the roots. At the roots, we know that y is equal to 0. So I substitute y 0, so I have 0 is equal to negative x squared plus 2x plus 3. This is equal to 0. All right, so this is a quadratic equation. We know how to solve this. Usually we like the coefficient of x squared to be positive, so you can divide throughout by -1. And then what you have is x squared minus 2x minus 3. This is equal to 0. Then you look for two numbers that when you multiply them, the answer is -3. And when you add them, the answer is -2. So those two numbers are -3 and +1. So you know how to factorize. Put your x, -3, +1 is equal to 0. So it means the first bracket is equal to 0, which means that x is equal to 3. For the second bracket, x plus 1 is equal to 0. This means that x is equal to -1. So then I write down the coordinates of these points. So my coordinates are 3, 0, because y is equal to 0, and -1, 0. Okay, so the y coordinate is 0. That's what we said at the beginning. Okay, so I have 4 points now that I'm going to sketch. So the first one was my maximum turning point, Then I have my y-intercept. Then I have my x-intercepts, which are also called the roots. Okay, then the last thing I need to determine here is the axis of symmetry. So remember, axis of symmetry, this is just the line that divides your parabola into two equal parts. So this axis of symmetry, the equation is just x is equal to minus b over 2a. So this is minus b. We already worked this out. This is minus 2. 2 times minus 1. This is equal to 1. So the line x is equal to 1 is the axis of symmetry. Okay, so now I have everything I need. All I do is I sketch it now. So now my sketch, this, draw my x and y axis, I label them. Then I need to plot the roots or the x-intercepts. So we say the roots are -1 and 3. So here this is -1, this is 3. Then we say the y-intercept is at 3. So that will be somewhere here. This will be a 3. And then the maximum turning point is at 1,4. So 1 will be somewhere in the middle and 4 is above. So it's here. So the point is somewhere here. Then what you do is you connect them with, you connect all these 4 points using your pencil with a smooth parabola. So here, go connect them as best as you can. Okay, and then I draw arrows at the end to show that it continues in that manner. It keeps going down to -infinity. Then my axis of symmetry, here I'll just use a different color. In the test, you don't need to use a different color. I'm just emphasizing. And this is the line x is equal to 1. So I need to make sure all my critical points are labeled. This is 1. This point here, I label it, it's 1,4. My x-intercepts are clearly labeled. I can see -1 there. I can see 3 there. This point here, 3. The 3 is there next to it. It's clearly labeled. My x and y axis are labeled. Then I should also label the graph. Y is equal to -x squared plus 2x plus 3, and then I am done. Get all your marks like that. So I need to see the x and y axis clearly labeled. I need to see the roots or the x-intercepts clearly labeled, the y-intercept clearly labeled, the maximum turning point or the minimum turning point clearly labeled, and then this line in red, your axis of symmetry, clearly drawn and labeled. Then it's fine. Do we have any questions on that one?
Miss,
Yes.
is it obvious that the value of axis of symmetry is always the same with the value of x at the turning point?
Yes.
Okay.
Mm-hmm.
And
Okay.
and the other
Yeah.
question I have is about the equation the equation you wrote down there.
Yes.
Is the master that we have to write it when we make y a subject of the formula, or we can write it the like as they gave it to us?
You can write either one, it's fine. The point is it must be labeled. I must know what parabola you have drawn. So if you label it in the original way it's given in the question, that's also fine.
Okay, miss.
Yeah. And another important thing is the shape of the parabola. I do not want to see something like this where you draw this and then you tell me that is a parabola. This definitely not. It must look smooth and it must look like a parabola. It shouldn't look like two straight lines that are meeting at an angle. So that's something to watch out for. Let's look at one more example of sketching a parabola. Let's say we have y is equal to x squared plus 6x plus 5. Now we are asked to sketch this parabola. The steps that we follow will be exactly the same. We need to determine the shape, the maximum or minimum turning points, our y-intercept, the x-intercept, then the axis of symmetry. After we've determined all those points, then we just draw a nice sketch. So with our shape, here the coefficient of x squared, this is 1. So this parabola will open upwards because 1 is greater than 0, so it opens upwards. Then this point here is a minimum, so it has a minimum turning point. So we look for our minimum turning point. Okay, now at the minimum turning point, we have x is equal to minus b over 2a. And here, this is minus 6 over 2 times a, which is 1. So we get x is equal to negative 3. Now if x is equal to negative 3, I need to work out the y coordinate. So y, I will substitute this negative 3 into the equation for y. So I have negative 3 squared plus 6 times negative 3 plus 5. Okay, so this, you work it out. This is 9 minus 18 plus 5. You get negative 4. So the coordinates of the minimum turning point are negative 3, negative 4. So that's the first point you're going to plot. Then we need the y-intercept. Okay, just remember at the y-intercept, x is equal to 0. So if x is equal to 0, we will just substitute that into our equation. So we have y is equal to 0 squared plus 6 times 0 plus 5. This means that y is equal to 5. So we can write this down as a coordinate. It's 0 because the x coordinate is 0. And then say comma y. So this is the second point that I have to plot on my graph. Just a moment. Okay. Then we look for the roots or the x-intercept. So here we have y is equal to 0. So again, I substitute into the equation for y. So I have 0 is equal to x squared plus 6x plus 5. So again, this is a quadratic equation. I will just rewrite it, x squared plus 6x plus 5. This is equal to 0. So this can be factorized. You look for two numbers that when you multiply them, the answer is 5. When you add them, the answer is 6. Those two numbers are 5 and 1. So you open your brackets, you put your x, you put your 5, you put your 1. Okay, so now the two brackets are multiplying and the answer is 0. It means the first one, x plus 5, is equal to 0. Or the second one, x plus 1 is equal to 0. This means that x is equal to minus 5 or x is equal to minus 1. So then you write this down as coordinates. So we have x minus 5, comma 0 or minus 1, comma 0. So y over here is 0 because that's what we said at the beginning. The y coordinate is equal to 0. So now I have my shape, I have my minimum turning point. I have my y-intercept, I have my x-intercept. The only thing left is my axis of symmetry. And axis of symmetry, we already know what it is because we used it when we're working out the minimum turning point. But it's always good to just write axis of symmetry. We have x is equal to minus b over 2a. So this is equal to negative 6 over 2 times 1, which is just negative 3. So here, say the line x is equal to minus 3 is the axis of symmetry. And then I have everything. I just need to sketch. So this is my x-axis, my y-axis. Those are clearly labeled. Then I plot my x-intercept. So the first one is minus 5. The second one is minus 1. Then my minimum turning point was at minus 3, minus 4. So that's maybe somewhere here. This point here will be minus 4. This is minus 3. And my y-intercept was at 5. So maybe somewhere over there. This is 5. Then I connect all these points using a smooth parabola. So try your best here. So this arrow continues. So there should be an arrow at the end there. Then it goes down as smooth as possible. Mine looks not so smooth, but on paper it'll be much easier. So I have arrows at the end, and then I indicate my axis of symmetry. I just use a different color. So this is my axis of symmetry. Then I label my axis of symmetry. This is the line x is equal to negative 3. My minimum turning point has to be labeled at the point itself. So I have minus 3, minus 4, and there it is. So you can see this intercept is clearly labeled. There it's minus 1. This one here, it's clearly labeled. It's minus 3. There it is. Then the turning point is labeled at the point itself. The axis of symmetry, you can see the line, there it is. And I have arrows at the end of my parabola to show that it keeps going up. It doesn't just stop over there. Okay, and then my y-intercept is also clearly labeled. And then that is how you would draw your parabola. Is that one fine? Okay, so these are the only two types of parabolas you will be asked to draw, one that faces up or one that faces down. So if it faces up, you do it in the same way I did this one. First, you must rewrite it in standard form, then work out those 5 things I gave you: the shape, the minimum or maximum turning point, the y-intercept, the x-intercept, then the axis of symmetry. Okay. Then the next thing we look at in this chapter is the nature of the roots. Now the nature of the roots, what we are talking about is these x-intercepts. What kind of x-intercepts do we have? Okay, so we ask, are they real? Are they equal? Are they rational? Are they irrational? Are they imaginary? So that's what we mean by their nature, not necessarily their value. Like if I look at this one, here's
Miss,
my root. Yes.
can you please help us to do one example for us how to construct an equation from a given points of the parabola?
We're still coming to that.
Okay.
That's right at the end.
Okay.
Yeah. Okay. So with the nature of the roots, if I look at the roots that I had over here, I had -3 and -1. If I look at my roots there, -3 and -1, these are both real numbers. They are rational numbers and they are not equal. Now, without solving this equation, I can classify my roots. So what we do in this section is we try and classify what kind of roots do we have. Now what will tell us the type of roots that we have is the discriminant. Now if you remember the formula for finding x, the quadratic formula, this was minus b plus or minus the square root of b squared minus 4ac over 2a. Now what I have under the square root over here, this is called the discriminant. Okay, so we sometimes shorten it, use the Greek letter delta. This is b squared minus 4ac. Now this discriminant tells us a lot. So if you know what your discriminant is, you can tell what kind of roots you have. Now if your discriminant is greater than or equal to 0, this means that you have real roots, because you'll put them under the square root, and the square root of any number that is 0 or positive, you will get a real number there. So if your discriminant is greater than or equal to 0, then you have real roots. Then you could also have a discriminant that is less than 0. Here, this means you have imaginary roots. Okay, that's the word imaginary. So your roots are imaginary. Now, when you have imaginary roots, this means you have a parabola like this, that looks like that, or like that. So remember, your roots are the x and they're the x-intercept. So you can see this parabola I've drawn up here does not intersect the x-axis, so it doesn't have any x-intercept. The same thing with this parabola over here, it doesn't intersect the x-axis, so it has no x-intercept, so it has imaginary roots. So those are the first two cases. Then you can have a discriminant that is equal to 0. Now if your discriminant is equal to 0, so this means your equation will be this: x is equal to minus b plus or minus the square root of 0 over 2a. So this will just be equal to 0, isn't it? So that means you will have only one solution. So you'll have, for example, x is equal to 2 or x is equal to 2 if you were to factorize it. So here you have equal roots. So sometimes you'll see it says repeated, or it says repeated. So that means the same thing. So if your discriminant is equal to 0, then you have equal repeated roots. Okay, then if your discriminant is greater than 0, that means it is strictly greater than 0. This means you have real roots, because greater than 0 falls in this category over here where it's greater than or equal to 0. So your roots will be real, but you will also have that the roots are real and unequal. So for example, here I have minus b plus or minus the square root. If I put any positive number here, 3 over 2a, 1 will be minus b plus the square root of 3 over 2a, and the other one will be minus b minus square root of 3 over 2a. So both of these are real, but they are not equal, okay? Because one is adding square root of 3 in the numerator, the other one is subtracting square root of 3 in the denominator. So you have real, but they are not equal. So the roots are only equal if your discriminant is equal to 0. If it is any other number here which is greater than 0, you have real and unequal. Okay. Then it also sometimes happens where you have your discriminant being equal to a square number. Now, if your discriminant is equal to a square number, what you have is that your roots, they are real because every square number is positive, and you have roots that are rational. Okay, so we can try it here. If I have minus b plus or minus, and I put a square number there, let's say 16 divided by 2a. This is minus b plus or minus 4 over 2a. The numerator over here is an integer. The denominator over there is an integer. So what I have is rational. Unlike the example that I gave previously where I had square root of 3. Square root of 3 is irrational. So when I subtract b there, I will not end up with an integer. So it is irrational. So when I have a square number, then my roots are real and irrational. Now if my discriminant is not a square number, then it means that I have irrational roots. Okay, so my roots are irrational. Then that's it. So you look at whatever discriminant you have, and then from there you should be able to classify. First, are they real or imaginary? If they are real, are they rational or irrational? Are they repeated, or are they equal or unequal? And those are the things that we look at. So let's look at an example where we have to classify the roots. So we're given this 2x minus 1. This is equal to 4x squared minus 2x minus 1. And then usually this question will say classify them without solving, because I can solve them and then I will look at the numbers and then say they are real, irrational, rational, or whatever. But these questions, when they say classify them, we don't want you to solve it. We want you to use the discriminant, then determine based on your discriminant what type of roots you will have. Okay, so first thing you must do is you must rewrite this in standard form. So you will multiply the 2 out there. So you have 2x minus 2. This is equal to 4x squared minus 2x minus 1. So you want everything on one side, 0 on the other side. So if you rewrite this, this is 4x squared. Subtract 2x on both sides, you get minus 4x. And then add 2 on both sides, you have plus 1. This is equal to 0. Okay, so we want to classify our roots. In order to do that, we need to know what our discriminant is. So our discriminant is given by b squared minus 4ac. Now my b, I can label my points. A is 4, the coefficient of x squared. B is negative 4, the coefficient of x. And c is the constant, whatever term doesn't have x. So this is 1. Then I work out my discriminant. This is equal to b squared. So this is negative 4 squared minus 4 times a, which is 4, then times c, which is 1. So this is 16 minus 16. This is equal to 0. So if my discriminant is 0, I look at the conditions that I gave. The first one was if the discriminant is greater than or equal to 0, then I have real roots. And then we said if the discriminant is equal to 0, then my roots are equal. Okay, so here I can classify my roots as real and equal. So I have real, equal. You can also include rational because the square root, under the square root you'll have 0. So you can also say rational. 0, you can also look at it as a square number. Right, so that is the nature of my roots. They are real, they are equal, they are rational. So when I solve this, I will get x is equal to maybe 2 or x is equal to 2. It's the same number like that. Is that one fine?
Miss,
Yeah,
why are we saying the discriminant is greater than or equal to 0?
is 0 not greater than or equal to 0?
Like where you wrote the real.
Yeah, it fits into
The,
this category, does it not? I
do
got
we know that?
0.
Oh,
Do we know what?
we know
Sorry.
we got 0.
Yes.
Oh, okay. Or it's fall under that category because of that, or equal to 0.
Yes.
Okay.
So you look at the tables and then you see which category does it fall under. Then whatever category it falls under, then you take that. Let me share the Word document so we can just see. Okay, let me know if you can see the table. This one here. Can you see table 2?
Yes, miss.
Okay, so this is like your category. So this, all these notes are on e-learning. So when you work out your discriminant, like I got 0 here, you should go each row by row and say, does it fall into this category here? Is it greater than or equal to 0? If yes, then you include that in your nature of the roots. Does it fall into this category? Then you include that in your roots. Does it fall into this category? And then you include that in your roots. So this is like your guide to tell you what type of roots you will have. Okay, let's do another example. With the next one, we have minus half x squared. This is equal to minus 2x minus 14 over 4. Then we are asked to describe or determine the nature of the roots without solving the equation. So here all we have to do is rewrite this in standard form. So first thing I can do is get rid of the denominators by multiplying by 4 on both sides. So when I do that, I have negative 2x squared This is equal to negative 2x minus 14. So I multiplied by 4 on both sides. So that's why this 4 is gone. And then this 2 here, when I multiplied by 4, there's a 2 left. And that's where I got negative 2x squared. Then I must bring everything to one side, 0 on the other side. So I have 2x squared minus 2x minus 14. This is equal to 0. Okay, then I can say what my a is. A is 2, b is minus 2, and c is equal to minus 14. All right, then my discriminant, the formula is b squared minus 4ac. Now b squared, this is negative 2 squared minus 4, and then a is 2, c is minus 14. So you work this out, squared minus 4 is 2. Okay, I got 116. Is that what you got? Okay, so then depending on what your discriminant is, you look at your table again. So 116 is greater than 0. So this means I will have real roots. And it is not a square number. So that means my roots will be irrational. And what else do I have? The roots are also unequal because it is not equal to 0. Okay, so if it was equal to 0, they will be equal, otherwise it is unequal. So what I have is real, irrational, and unequal. That is how I would classify them. Is that fine?
Yes, ma'am.
Okay. Then let's look at another question. Now we are given this equation. We have 3x plus 1. This is x squared plus m plus x. Okay, now with this question, it's a little bit different in that we have a second variable, but this is a quadratic equation in terms of x. So m is a constant. We just don't know what the value of m is. Now what we're asked to find is the values of m so that this has real roots. So we want to make sure that this has real roots. Okay, now real roots, you need to go according to your table. Real roots means that this is greater than or equal to 0. That's what it means. Okay, so if we have a discriminant that is greater than or equal to 0, then we have real roots. So we will again rewrite this in standard form, and then we work out the discriminant and make sure it is greater than or equal to 0. So when we do this, first we must multiply this out. So we have 3x plus 3. This is equal to x squared plus m plus x. So everything on one side, 0 on the other side. We have x squared So we have x squared plus m plus x minus 3x plus 3, and this is equal to 0. So you need to work out the coefficient of x. So you combine all the terms with x together. So it's this 2, you have x minus 3x. So I have x squared minus 2x. And then these two terms, m and 3, those are constants. They don't have an x. So I can write
Miss,
them in, yeah,
why the other 3 is positive?
it should be negative. Yes, it should be negative. Minus 3. Thank you. Okay, I think now it's fine. Okay, so here you then again identify your a. A is the coefficient of x squared, which is 1. B is negative 2. And C is everything else that doesn't have an x. So it's not m alone, it's not negative 3 alone, it is m minus 3.
Hmm.
You see, this is equal to m minus 3. All right, so is that fine? How we identify your A, B, and C?
Uh, Repeat, Miss, from the equation, from here, from the last
From
equation
here,
you wrote.
this one here?
Yeah, Miss.
Okay, so here your A is just the coefficient of x squared, which is 1. And then B is always the coefficient of x. Then you can see these two terms together do not have an x. So together they must make C.
Okay.
Yeah. So then now that you have your A, B, and C, you know the formula for the discriminant. This is equal to B squared minus 4AC. B squared, this is minus 2 squared minus 4 times A and times C, which is m minus 3. Okay, so we can just simplify this. This is 4 minus 4 times m minus 3. So this will multiply inside. Then we have 4 minus 4m plus 12. I simplify this. This is 16 minus 4m. So this is my discriminant. But then you need to remember at the beginning we said we want real roots, and to have real roots our discriminant must be greater than or equal to 0. So now that I have my discriminant here in terms of m, I will say 16 minus 4m is greater than or equal to 0, because that's what it means when your roots are real. Then we solve this inequality. Remember, we've done inequalities, so you can add 4m on both sides. You have 16 is greater than or equal to 4m, and then you can divide by 4 on both sides. We have 4 is greater than or equal to m. Now, if 4 is greater than or equal to m, this means that m is less than or equal to 4. And this is your solution. So what this means is in your quadratic equation over here, or even right at the beginning, if you put any value of m over here that is less than or equal to 4, then the quadratic equation you get will have real roots. Okay, so you can try to put put a value of m that is greater than 4. You can put 5, for example. Try and solve that. You will see that you do not have real roots. Your roots are imaginary. Okay, then the next one we'll look at is we are given this equation 2x squared plus x minus 2kx minus k is equal to 0. So here I want, it is already in standard form because everything is on one side and I have 0 on the other side. It's just that the values of a, b, and c are not so clear. So here I can see these are the terms that have x as, that have an x. So what I do is I will factorize x. So I have 2x squared plus x, and I have 1 minus 2k minus k. This is equal to 0. So from here I can now identify what my a, b, and c are. So a, we said, is the coefficient of x squared, which is 2. b is the coefficient of x, which is 1 minus 2k. And c is the term that does not have an x, which is minus k. Okay, now what we are told about this equation here is we have to show that the roots are rational and unequal if k is an integer. So rational, that means our discriminant is a square number. So we are told to show that the roots are rational and unequal. Okay, so we need to remember what these two words mean on our table. Now rational, this means that our discriminant is a square number. And then unequal, this means that the discriminant is not equal to 0. So we need to show these two things. And this must be true when our value of k is an integer. So what we do is we need to show that our discriminant is a square number and it is not equal to 0 for any integer k. So we have our a, b, and c. They're over here. What we do is we just substitute them into the formula for the discriminant. So we know that our discriminant is equal to b squared minus 4ac. Now b squared, this is 1 minus 2k squared minus 4. A is 2. And then c is minus k. Okay, close the bracket there. So we simplify this as far as possible. So this one, 1 minus k squared, this means 1 minus 2k times 1 minus 2k. Then I have plus 8k. So we multiply this. We have negative 4 and negative k. That would give you positive 4k. Then times 2 is 8k. Then we know how to multiply these two brackets. 1 times 1 gives me 1. 1 times minus 2k is minus 2k. Minus 2k times 1 is minus 2k. Minus 2k times minus 2k is positive 4k squared plus 8k. So simplifying this, I have 4k squared and then negative 2k minus 2k plus 8k. This is just equal to 4k and then plus 1. Now this is a quadratic equation, a quadratic expression. So we can factorize it. You look for two numbers that when you multiply them, the answer is 4. And when you add them, the answer is 4. So those two numbers are 2 and 2. So you open your brackets, you put your variable, then we say the two numbers are 2 and 2, and then we divide by the coefficient of k. So divide by 4, divide by 4. Then you simplify this, you get 2k plus 1, 2k plus 1. Now these two brackets are exactly the same, so I can write this as 2k plus 1 squared. And remember, this is the discriminant that I was working out. Now, what we said at the beginning was, if my discriminant has rational roots, I need to show that my discriminant is a square number. And when I look at what I have 2k plus 1 squared. So this is a square number because k is an integer. So whatever integer you put, let's say you put 3, you say 2 times 3 is 6 plus 1 is 7. 7 squared is 49. 49 is a square number. You can put 0 if you like. 2 times 0 is 0 plus 1 is 1. 1 squared is 1. 1 is a square number. So this discriminant is always going to be a square number. So it meets the first condition that our discriminant is a square number, so we'll have rational roots. And then the second one, we said unequal. Unequal means the discriminant is not equal to 0. Now this 2k plus 1 squared can never be equal to 0 because what I have over here, k, is an integer. So if you put any integer over there, you can never make that 2k plus 1 equal to 0 because the number you need to substitute for k to make 2k plus 1 equal to 0 is negative a half, but negative a half is not an integer. So that is why your roots are real, they are rational, and they are unequal. So you can write that as a statement. So the discriminant, which is equal to 2k plus 1 squared, is a square number. Therefore, equation has rational roots. And we also have the discriminant, which is equal to 2k plus 1 squared is not equal to 0 for any integer k. And therefore, the roots are not equal. Okay, and then that concludes what it is we were asked to work out. Is that one okay? Or is it fine? Okay, then we move on to the question that was asked earlier, that how do we determine the equation of a parabola if we are given points? Now, if you are given the roots and a point on the line, there's a way to do it. If you are given the turning point and another point on the line, there's one way to do it. So these are all highlighted in your notes, and we'll look at how to work them out just now. And if you are given 3 points where they are not roots, they're just points that lie on the line, there's another way to do it. So we'll look at all three of those, and those are the only three possible ways you can be given this question. So let's say, for example, we want to determine the equation of a parabola that has, so we want the equation of a parabola with the roots 1 and -3 and a turning point of -1 and 8. Now here, when you are given the roots of the parabola, you should know that the parabola can then be factorized as y is equal to a, x minus your first root, which is alpha, and then x minus beta, which is your second root. So this is one of your roots, and this is also a root. Okay, so if you know the roots, what you do is you substitute them over there, because when we have the roots, we always factorize it, and then we say it's equal to 0, and then we solve for the roots. So first thing you do, you substitute, you say y is equal to a. Now this a over here, there are sometimes when we get equations like this: 2x minus 1, x plus 2 is equal to 0. I will sometimes divide by 2, then I have x minus 1 is 0, x plus 2 is equal to 0. And if I have another one, which is 3x minus 1, x plus 2 is equal to 0. These two equations, these two, they have the same roots, but you can see they are not the same parabola, because one has a 3 there and this one has a 2 over there. So they are not the same. So you must always include this a over there for numbers that you might have divided on both sides of the parabola. Okay, so that is just to note why we put an a over there. Okay, so I have y is equal to a, then I say x minus my first root. My first root is 1, so I say x minus 1, and then my second root, x minus -3. So then I will simplify this. This is just y is equal to a, x minus 1, and then x plus 3. Now I am told that it has a turning point, -1, 8. Now the turning point is a point on the parabola, so that turning point must satisfy the equation of the parabola. So that means when I substitute y is equal to 8 there, and x is equal to -1 over there, it satisfies the parabola. Okay, so I substitute. I have 8 is equal to a, then my x is -1 minus 1, -1 plus 3. So here we now try and solve for a. I have -4a because this is -2 and this is +2. When I multiply them, I get -4a. This is equal to 8. Then I divide by -4 on both sides. I get a is equal to -2. Then now I rewrite the equation. Y is equal to -2, and then where did I simplify? There it is. So I now just substitute the a over there. And then I have x minus 1, and then I have x plus 3. So you can also rewrite this in standard form. If the question is not specific, then you can leave it like that. If the question, for example, says find the equation y is equal to ax squared plus bx plus c, such that it has the roots 1 and minus 3 and the turning point minus 1, 8, then you must write it in this form. And when you have it like this, you know how to work it out. You just multiply, and then the same thing with the x, and then the 2 will also multiply what you get. And that's the equation of your parabola. Now you could also be given the turning point. So let's say we are told that the turning point is 2 and minus 1. And then we have y-intercept equal to 3. Now with the turning point, remember I said you can also complete the square in order to work out the turning point. So if you have your equation, you have y is equal to a x minus p squared plus q. This you get by completing the square. Okay, so this formula you would get by completing the square, and when the square is complete, this will give you your coordinates of the x-coordinate of the minimum or the maximum turning point, and then this will give you the y-coordinate of the minimum or maximum turning point. So when you're given the turning point, you can use this formula and you'll just substitute your P and Q. This is your X, your P, and this is your Q. All right, so we can substitute those in there. Then what we have is Y is equal to A. I have X minus 2 squared plus Q, which is minus 1. So rewriting this, I have, this is A x minus 2 squared minus 1. So this is the general equation. I just need to work out what A is. Now I'm told that the y-intercept is equal to 0. Now the y-intercept has the coordinate 0 and 3 because at the y-intercept x is equal to 0. So what we'll do is we'll substitute the x and y coordinates, the 0 and the 3 in there. So we have 3 is equal to a, 0 minus 2 squared minus 1. And then we solve for a. So I have 3. This is equal to a, negative 2 squared minus 1. 3 is equal to 4a minus 1. Then what we do is we add 1 on both sides. We have 4a is equal to 4. Then divide by 4, we get a is equal to 1. So then the equation of this line will be, this parabola, sorry, this is a, which is 1, x minus 2 squared minus 1, which is just x minus 2 squared minus 1. Okay, so that's when you're given a turning point and another point that lies on the line. Now you can also be given just 3 points that lie on the line. Now the way you work this out is you will have to solve these 3 equations simultaneously. So let us very quickly look at this example. Now this is exercise 4.7.2.2. Now we are given these points A, which is -4, 0, B, which is 1, 0, and then C, which is -2, 12, -12. Okay, so we have 3 points, but what we notice about these 3 points is 2 of them are the x-intercepts. So these are the roots. So this one and that one, these are our roots. So we can solve them in the same way that we did the very first one. We can also substitute them into the formula y is equal to ax squared plus bx plus c. You can do that. You'll have 3 equations. Then with those 3 equations, you can make one variable the subject and then substitute into 2 of the equations, then solve those 2 equations simultaneously. Okay, so there isn't just one way to solve this. So here I know that my roots are -4 and 1. So I have y is equal to a x minus alpha x minus beta, because I know what the roots are. The roots are when y is equal to 0. So here when I rewrite it, I have y is equal to a x minus -4, which is x plus 4, and then x minus 1. And then this point here lies on the line, so that means it must satisfy the equation. So I will substitute -2 over there and then -12 over there, and that will give me the equation of my parabola. So here -12, this is a, and then I have x, which is -2 plus 4, and then I have -2 minus 1. So here I have -12. This is a, this is 2, and this is -3. So I have -6a is equal to -12. This means that a is equal to 2. Okay, so now I have the values of a. The value of a, I will just substitute a there, and then I have the equation of the line. So I have y is equal to a, which is 2, x plus 4, and then I have x minus 1. And this is the equation of my parabola. Is that one fine? And do we have any questions on that one? Okay, if not, let's do the last question in the exercise. We have, we're given to say y is equal to ax squared plus bx plus c. Okay, that is the equation of the parabola. We have to determine what a, b, and c are. Oh, sorry, I'm not done. I'm not done, because I didn't find out what a, b, and c are. I just found the equation of the parabola, which is not enough. So what I do here is then I must multiply out. So I'll multiply this, write it in standard form. So I have y is equal to 2x plus 8, x minus 1, and then you know how to multiply. So this is 2x squared minus 2x plus 8x minus 8. Then we simplify. We have y is equal to 2x squared plus 6x minus 8. So now I can say a is equal to 2, b is equal to 6, and c is equal to minus 8. Now I am done, because the question says determine a, b, and c, not just find the equation of the parabola. Okay, so read the question carefully and make sure you understand what it is asking you for. Okay, let's look at the last one. We are told our equation, or the equation of the parabola, is ax squared plus bx plus c. We have to find the values of a, b, and c if we have a turning point, which is 2 and minus 3, and this is a point on the line, which is minus 2, and 5 is a point on the line. So with this one, we just use the formula for the turning point, which is y is equal to a x minus p squared plus q. Now your x coordinate of the turning point, this will be your p, and then the y coordinate of the turning point is your q. So you just substitute them. We have y is equal to a x minus p, which is minus 2 squared, plus negative 3, which is just minus 3. Then this point, we are told, lies on the parabola. That means it must satisfy the parabola. So you substitute x for minus 2 and y is 5. So I have 5. This is equal to a. X is minus 2 minus 2 squared minus 3. So I have 5. This is a. This is minus 4 squared minus 3. I'll just rewrite this as 16a minus 3. This is equal to 5. This means that 16a is equal to 8. A is equal to a half. Okay, so now I will substitute a half over there, expand the brackets, write it in, easily say this is A, this is B, and this is C. So I have y is equal to a half. Then I have x minus 2 squared plus minus 3. Minus 3. So expand this bracket. You know how to square. So this is half x minus 2 times x minus 2 minus 3. Then you know how to multiply. So this is half. Then I'll end up with x squared minus 4x plus 4 minus 3. This is half x squared minus 2x plus 2 minus 3. This leaves me with half x squared minus 2x minus 1. So now that it is in standard form, I can say a is half the coefficient of x squared, b is negative 2, the coefficient of x, and c is negative 1, the constant term. Okay, so with that, we are done. Do you have any questions before we call it a day? Or is it fine? that there are no questions and everything is fine, then like that, we are done with the syllabus. We've covered everything. The only thing left for you guys now is to study for the test. So that the test date is on e-learning. So please study for that. Make sure you're ready. So you have the whole of next week to prepare. So I don't have anything new to teach, so I'll wait for questions. So if I get questions, then I'll let you guys know that we have class. Otherwise, you can contact me here on Teams, send me an email if you have any problems, and then I will see how I can help you. Okay, so have a good weekend. Then if people send me questions, then we'll have a class. Otherwise, we will not. Just get ready for the test.